So exponential form of our complex numbers. How do we express complex number in exponential form? So from, you know that we have polar form of complex number, which is z equal to r into bracket cos angle plus I sine angle. So this is polar form. So in exponential form, it becomes r e power I angle. So this is exponential form. This is exponential form of a complex number. That is the exponential form of a complex numbers, where e power I angle equal to cos angle plus I sine angle. That is e power I angle. So now, if e power I angle equal to cos angle plus I sine angle, so what is e power negative I angle? What is e power negative I angle? Meaning that our angle is the one which is negative. So this is cos negative angle plus I sine negative angle. So remember, from when you have a cos of a negative angle, is the same as cos of that angle. When you have sine of negative angle, is the same as negative sine angle. That is opposite angles. Cos of negative angle is equal to cos of angle. Sine of negative angle is equal to minus sine of that angle. So meaning that e power negative I angle will be equal to cos of angle minus I sine angle. So we have e power negative I angle, and now we have e power I angle. So but exponential form of a complex number, the formula is z equal to r e power I angle. Then, so this is equation 1, and this is equation 2. So we're going to add, let us add I1 plus I2. So if add I1 plus I2, that is e power I angle, which is equal to cos angle plus I sine angle, plus e power negative I angle equal to cos negative angle, equal to cos angle minus I sine angle. So we are adding. If we add e power I angle plus that one, e power I angle plus e power negative I angle, the answer is cos angle plus cos angle, that's 2 cos angle. Then I sine angle minus I sine angle, that is 0. So this implies that we can divide by 2. This implies that cos angle equal to, we're going to divide by 2, e power I angle plus e power negative I angle divided by 2. So this is the value of cos angle. Our cos angle will be equal to e power I angle plus e power negative I angle divided by 2. So now the second one, we're going to subtract that one. We take I minus I2, Roman 1 minus Roman 2. So that is e power I angle, which is equal to cos angle plus I sine angle, then minus e power negative I angle, which is equal to cos angle minus I sine angle. So what will be the answer? E power I angle minus this, that is e power I angle minus e power negative I angle. Then cos angle minus cos angle, that is 0. I sine angle minus minus becomes positive, that is 2I sine angle. So what is sine only? We make sine as subject of the formula. I'm going to make sine angle as the subject of the formula. So our sine angle will be equal to e power I angle minus e power negative I angle divided by 2I. So that's the formula for sine angle. Then, how do we call that one? Those are Euler's formula. We call them the Euler's formula. So the Euler's formula are cos angle, which is equal to e power I angle plus e power negative I angle divided by 2, and sine angle equal to e power I angle minus e power negative I angle divided by 2I. Those are Euler's formula. So where do you use those formulas? We use it when we are doing linearization of a complex number. So we're going to see examples. Number 1, express the complex number z equal to root 3 plus I in exponential form. Is there anyone who can try this? So as you're trying this number, after trying this number, I'm going to do number 2. You just first try this one, I see how you can do it. So then after doing this number, let us do the equation together. We're going to express z, I'm going to express z equal to root 3 plus I into exponential form. And remember, exponential form is r e power I angle. So what do we need? We need r as the modulus of z, and we need the angle as the argument of z. So we're going to find r. R is the modulus. There our a is root 3, our b equal to 1. So r is the modulus, which is the square root of a squared plus b squared. So now our r is root a squared, which is root 3 squared plus 1 squared. So now this is r is root 4, which is 2. So our radius equal to what? To 2, which is the magnitude. So after getting the magnitude of z, we're going to find the argument. How do we get argument? It is tan alpha, which is equal to b over a. So now, what is tan alpha? Tan alpha is going to be, what is b? B, it is root 2, it is 1. Then a, it is root 3. So now alpha is tan inverse of 1 over root 3. And this is 30. Tan inverse of this one is 30. So our alpha is, so just is a matter of finding tan inverse of 1 over root 3. So tan inverse of 1 divided by root 3. The answer is 30, which is pi over 6. So our alpha is pi over 6. So this is the alpha, not angle. So to get angle, we're going to consider quadrants. We have a circle. A circle contains 4 quadrants. But as you can see, our A is positive and B is positive. Our A is positive and B is what? Positive. So they have to meet here in the first quadrant. They have to meet here in the first quadrant. So in the first quadrant, our angle equal to alpha. So therefore, our angle will be pi over 6. So after getting angle equal to pi over 6, what is our z? Because now we have the argument and we have the modulus. So our z, which is r e power I pi over 6. So our z is r, which is 2 e power I pi over 6. So that is the polar form of that complex number. I hope there is no any question here. Do you have any question? Yeah, there is no any question. This is 2 e power I pi over 6. So let us go to number 2. Number 2 is saying express the complex number -1 plus I root 3 in exponential form. So it is the same way. What you have to do is z equal to r e power I angle. So we're going to find what? We're going to find r, which is the modulus. We find the argument of z. So what is z, our z? Our z is -1 plus I root 3. So the modulus of z, which is r, is going to be square root of -1 squared plus root 3 squared. So then this is 1 squared, -1 squared is 1, root 3 squared, that is 3, 1 plus 3, that is 4, root 4, that is 2. So our r is 2. So after getting r equal to 2, what will be our argument of z? So tan alpha equal to b over a. But as you can see, let's say a equal to 1, b equal to root 3. When you're looking for argument, we don't use negative sign. We just use positive. Those signs will help us to know to get or to understand where the location of what? Of this complex number on the circle. So then tan alpha is root 3 over 1. So alpha is tan inverse of root 3. So then alpha equal to pi over 3, which is 60. So after getting alpha, what will be the argument? We just consider the circle to know where, or to know exactly the location of that complex number, where it is located. So our a, it is negative. If a is negative and b is positive, they are here in the second quadrant. If they are there in the second quadrant, we know that in the second quadrant, we know that angle equal to pi minus alpha. So which means that our angle will be pi minus alpha, which is pi over 3. So the answer will be 2 pi over 3. So this is our argument. After getting our argument, we're going to find, I just write z in the polar form, which is, in the exponential form, which is e power I angle. Z equal to r, e power I angle. So we have r equal to 2. We have angle, which is 2 pi over 3. That is I, 2 pi over 3. That's how we write algebraic form into exponential form. Let me just give you exercise. Exercise number 1, express the following complex number numbers into exponential form. So we have a, z equal to a half plus I root 3 over 2. We have b, z equal to -1 minus I. We have c, z equal to 1 plus I. So try to do those exercises to help you to understand very well how we can express algebraic form into exponential form.